Hello everyone, I am back with another video of a hosting system. In the previous lecture, I have discussed about the hosting system, their function and their some of the component. So let's move further. So I have discussed this thing earlier in my previous video. What is Derrick, what is substructure and the block and tackle system. I haven't discussed about the drawbox, but I will discuss, right? So these are the main component. So yeah, we have discussed this thing. Now today uh, I'm going to discuss, yeah, last class we have discussed till now mechanical advantage. So for you people, if you are new to the my YouTube channel, so let me explain you again a little bit about the mechanical system. If we talk about the mechanical system or mechanical advantage, not system, mechanical advantage, in that particular case is basically the M is nothing but uh, how much amount of load you are lifting, and in our case W is the load you are lifting, and the how much amount of the effort you are applying. Effort you are applying means how much amount of the means force you are applying to lift this weight, right? So that is F in the right now. In this case, the basic meaning of the mechanical advantage is, so applying a minimum weight, lifting a applying a minimum force, lifting a maximum weight. This is the uh, best way to understand. If I want to understand, make you understand in the other way, so how we are going to understand, let me draw the one of the beautiful picture, small arrangement of block and tackle system, right? So I am saying that this is the arrangement we are talking about, right? And this is the traveling block. I am saying that there it is, hook is there, right? Hook is there. I am saying that from the hook there is a weight W which is loaded, and this is the fast line F I am representing over here, and this is the dead line FD or FS, you can say, according to the nomenclature. You can search in the book. Okay, so these are the pulley, 1 pulley, 2 pulley, 3 pulley, 4 pulley, 5 pulley. These are the pulley system, right? So how we are going to understand about this mechanical advantage? For an example, let's suppose W is having a 50 kg of load. We want to lift, this is the drawbox, this side is drawbox. We want to apply this force to lift this 50 newtons of a, or 50 lb lbf of load, right? So how we can understand this thing? So if you are a good in the physics, or you know better something a little bit about the physics, so let's suppose this is the small pulley system, right? And this is the two rope, and this W is there, right? So now if you want to lift this weight is W is divided into W by 2 and W by 2, right? You may aware about this thing, right? So in this case, this here it is, in this case W by 2 is divided in this pulley, and W by 2 is divided in this pulley, and this further is this W by 2 is divided in between two rope, right? In between two ropes. So if you understand this thing, so can I say here, the number of rope is increasing, the weight is divided, right? Can I say that if the number of rope is increasing, the weight is divided into two part, right? Here it is. Okay, so here I can say that in this case, this W by 2 is further divided into two parts. It will be W by 4, it will be W by 4, and in this case W by 4, in this case W by 4. Now this rope is continuously, means here it is W by 4 you will experience, and this rope is also experience the W by 4. Means from this FF, fast line load, FF is represented as a fast line load. So now earlier was the 50 kg Newton. Now you are applying, in this case, FF. If I have to write FF over here, FF, let's suppose I am writing FF. So now FF is equal to W by 4 I am writing. So now 500, W is 500 divided by 4. You will may get, I think, some value. This is 250 and this is 2, and then again 250, I think 125, right? You check the using calculator. So 125. Now this FF is equal to 125. What does it means you are applying only 120 lb of load to lift 500. This is the main things, right? This is the main thing. If you talk about the definition, this is W, this W is 500 and FF is how much? 125, right? So can I say this is the best way to understand the mechanical advantage, right? So mechanical advantage is nothing but the applying minimum effort to lift maximum weight, right? Let's move further to understand. As I told you, the number of sieve in the crown block is more than the number of sieve in the traveling block. The reason behind it, it's one of the sieve is goes through the fast line load. That's why in the traveling block, in the crown block, the number of sieve is more comparative to the traveling block. Traveling block is this is moving, right? A number of active line, I will explain this thing, don't worry about it. Okay, let's move to the further. So this is the one of the best thing you need to understand over here, that this best thing is what I am talking about. So let's start the things. Before doing this calculation, I would like to explain something very interesting to you. Let's suppose we have this one rope is attached with the mkg of mass, right? I am assuming that this velocity is Vd, right? And his velocity is Vf, and Vd is the traveling velocity I am assuming, and the Vf is the fast line velocity I am assuming. So what happened in this general case, if you want to pull this thing by 1 meter, this will rise by 1 meter, right? If you want to pull by 1 meter, this will rise by 1 meter, this will rise by 1 meter. But in another scenario, if we talk about, let's suppose we have now this case and this case, there is, let's suppose this is the traveling block I am assuming for this instant. But when you want to pull 1 meter of this pulley, this fast line velocity, it will rise only half. It will rise only half. So there is a very important relationship. What is happening over here? The number of lines is increasing. Earlier was a single line. Now the number of lines is 2. It is half. If the number of lines will be 4, then it is you can say the velocity will be a half, 1 by 4 something, 1 by 4. So number of lines is increasing, then the velocity of the traveling block, or number of lines is increasing. We can say that the velocity of the fast line is inversely proportional, right? So what does it means? Like if you have this pulley system attached with the 4 rope, if you want to lift this by 4 meter, then this system will rise by 1 meter. This is the concept you need to remember. And now let me write one of the relationships, so that you don't be confused about this thing. Just remember this part, what I want to write, right? Remember this part of what I want to write over here. So I think everything is erased now. So yeah, so I wanted to write over here the traveling block speed, which is equal to the fast fast line speed divided by number of supporting line, or you can say number of lines, as we discussed. So we can write traveling velocity we are assuming over here Vd, and the fast line velocity we are assuming Vf, and n is the number of line. Remember this relationship. This relationship is very important while solving this calculation. Yeah, this is all about this relationship. Let me now figure out the something very important over here. So as you are assuming in this diagram, as you can see in this diagram, this is the free body diagram we are assuming over here. This is a free body diagram. This W is the weight, this FF is the fast line force, and this Fs is the fast line load. Yeah, load या force. Yeah. So what we need to understand that we have learned about the power, right? We have learned about the power. So power is basically what? If I have to write in this case, if I have to write power, input power, so what can I write? Input power, if I have to write, then in that case power is nothing but the velocity into force into the velocity. So in this case Ff is the force. Input force means this much amount of the force you are applying to lift some weight, multiply with the velocity of what? Velocity of the fast line, this velocity we are talking about, or Ff is the load we are talking about, right now I have drawn only this diagram, right? So this is the input power I have wrote over here. Similarly there is a output power. There is a output power. So that output power is what? That output power is what? So now output, you are giving the input, this input to lift whom? This W weight, W amount of load you want to lift, and when you want to lift this W amount of load, they are having some velocity through some velocity they are lifting. That velocity we are assuming that the traveling velocity, that is Vd. So in this case if I have to write output power, that is in this case W is the load and Vd is the traveling velocity. So now these two things is written over here, right? Two things is written over here. I will explain this thing, how this thing has been came, so don't worry about it. Okay, so first thing you remember, input power has been fast line load multiply with the fast line velocity. Output power, or you can say hook power, W is the force and Vd is the velocity. Now we want to write efficiency. Everything is measured by the efficiency, right? You people are measured by the marks, we as a faculty we have measured by the our quality of a teaching, right? So efficiency, as we know that efficiency is nothing but the P output divided by P input. Simple. So P, if I have to write P output, just now we have calculated P into Vd divided by P input, Ff fast line load, Vf is the fast line velocity. And this expression we are deriving only for the ideal condition. Ideal condition, what does it mean by ideal condition? We are assuming that in this case there is no friction between the pulley, right? We are assuming this thing. So if you remember that from the mechanical advantage, m mechanical advantage is nothing but the W divided by the fast line load, and which is equal to n. Do you remember this thing? Last class we have discussed about when the number of rope is increasing, then the mechanical advantage is also increasing, right? So from here if I have to write if I have to write the value of W, from this case Wf is equal to Ff is equal to n. So if I have to write W is equal to n into Ff, right? This is the calculation. So W we can write n multiply with the F, and this case is only possible in the ideal condition, right? Remember this thing, this case is only possible in the ideal condition, not in the actual condition. Actual condition means there is a friction between the pulley and and there is a mass of the rope, right? So these, the friction between the pulley we are neglecting and the mass of the rope is also neglecting. So this is the ideal condition we are deriving this expression. So remember this formula, right? This formula, and the another relationship, just now we have determined that the Vd is equal to Va by N. This is the relation we have learned right now. So we want to put this value of Vd over here, Vd over here, and the W value over here. So let me make this board clear. What will be the output will come. Uh, let me do the calculation and the output will come. So E, as I told you, W can be written as FF multiply with N, right, in close bracket, and Vd can be written as Vf divided by N, and at FF multiply by Vf. So if you do some calculation, this Vf will cancel out with this Vf, this N will cancel out with N, and this FF will cancel out with FF fast line. So it will be equal to the 1. So what does it means? This 1, what is indicating this thing? Efficiency is 1, that means 100%, which is not possible, E is equal to 1, which is not possible. This is only possible in ideal case, but as an engineer we know that there are many losses, different type of losses is there, friction is there, some other factor is also include there, right? So I just want to understand that what will happen, what will be the value of this efficiency in the actual condition. So let me derive this expression for the actual condition, keeping all the things same. Just there is a what we have substitute, we need to take care of that particular things, right? So what, for actual condition, for actual condition, or you can say non-ideal condition, in that case E will be Pf divided by Pi, and W will be remain same because the value we have substituted earlier in that case. For the ideal case, I have assumed that in the previous lecture that mechanical advantage W by F is equal to N only when we are assuming that there is a no friction, right? In this case, now Vd can be also written as Vf divided by N, as we know that, and the denominator is the input power, and that input power we have already derived, Ff multiply by Vf. So now what will happen, this Vf and Vf will be cancel out, you will come out with the sum of the beautiful expression. That expression will be W by N by Ff, right? And some book they are writing Ff is equal to W by Ne, okay, Ne. So W is the load, hook load, you can say W is the load, and N is the number of line, FF is the fast line load, E is the efficiency, right? E is the efficiency. This is the case you need to remember. If someone saying that while solving the numerical, you can they will ask calculate the fast line load, calculate the dead line load. So you need to understand this thing, right? Now before jumping to this derivation Derrick part, let me give you the clear justification or clear some of the diagram, so that you can understand how the things is happening, right? So here for you people I am making one of the diagram so that you can understand, right? So what I want to say, this is the one block is there, there is another 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 block, right? So what we want to know, just this rope is going in this way, and this is going in this way, this is going in this way, and this is going in this way, right? I am not good in this, and this is your traveling block, right? This is your traveling block, this is your rope, and this is your hook, right? So as I told you, this load is divided equally. This W is divided into the W by N, or W by 2 over here, and W by 2 over here, W by 2, W by 2. And now this W by 2 is further divided into the W by 4 in this case, so this here it is W by 4, W by 4, and W by 4, and W by 4, W by 4, W by 4, right? If you are not able to understand this thing how it is happening, just refer to the previous lecture, you will understand. So what is the logic over here? Logic behind is that this W is, this W load is divided into this two part, this pulley and this pulley, right? So in this pulley they are experiencing W by 2 load, W by 2 load, and this W2 by load is lifted by this load W by 2 is divided into this part. So what I am saying that the number of rope is increasing, the load distribution is also load in the rope is also divided. So can I say if one rope is attached, means the W load is there. If two rope is there, then the load is W by 2. If three rope is there, W by 3, and four rope is there, W by 4. So can I say that this is nothing but the W by, can I write W by N, means the N rope for the W by N? Can I write W by N? Yes, we can write W by N, right? So now if again I have to write this diagram, if I have to draw this diagram, so I can draw this diagram in very easy way, right? This easy way is, yeah, one rope is over here, yes, one circle is there, why it is not working? Yeah, one circle is there, in between this, and in between this. Yeah, this is now roughly I must drawing this diagram, traveling block. Now can I say W by N, 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 right? This is FD, dead line you say, or FS you can say, or this is fast line, FS. This is also W by N, right? Just remember this thing. The beauty of this thing you will understand right now over here, right? Okay, so this is the FD is nothing but the static load, right? This part, this pulley is, this rope is not moving, right? So this FD is equal to W by N. But in this case, when your FF, in this case the rope is moving just through the draw box, so there is a friction. In that case, FF is, just now we have determined, FF is nothing but W by NE. Yes, W by NE we have determined, right? Now we want to calculate the total Derrick load is acting on the traveling block, total Derrick load acting. What is the total Derrick load? FD. What is the total Derrick load? So these all the system R is on the Derrick floor. So how much amount of the Derrick floor load is experiencing? So that load is nothing but a W hook load, fast line load, dead line load, or FS you can say, and this one is the fast line load. These three load is experiencing over the Derrick. So that load could be W by W plus FF fast line load plus FD or FS, whatever you write. So this load is experienced by the Derrick, and that load could be W by the hook load is W, right? Then the fast line load, as we discussed, W by NE, and plus FS is nothing but the dead line load, that is nothing but the N. If you solve this thing, if you take a LCM over here, NE, you will get the WN plus W plus WE. I think I made a mistake. W, yeah, E will be also here. Okay, so now what is the value here, final output you will get after doing some calculation or some elimination or taking common something. So you will get if you observe carefully, w is everywhere, w is everywhere. I can take the common of this w, this w I can take the common. So what will remain over here at this particular place? So if I take, can I say 1 will be there, can I say e will be there, can I say ne will be there, and divided by ne, and this is the multiply with the w. So this w is called Derrick load, Derrick load, right? This is Derrick load. In upcoming class we will going to learn about the Derrick efficiency factor. Okay, we are going to learn about the in upcoming class Derrick efficiency factor. Let me close